Gravity from the sun and moon work together to give us tides here on Earth. And in return, Earth's gravity is cracking the moon's surface. Talk about a bad trade-off. Hey there, Kaylee here with DNews. Scientists have a pretty good idea of how the moon formed. The current theory is that about 4.5 billion years ago, a Mars-sized object called Theia collided with the Earth, ejecting material into space. This material then collected over what was left of Theia's core, forming Earth's only natural satellite. Unfortunately, we are slowly crushing it. For most of us, the moon is a cold, unchanging structure pitted with craters from impacts. However, current images of its surface prove that it is much more active than previously thought. Distributed throughout its entire surface are over 3,000 lobate scarps, which are thrust faults indicative of compression. There is a pattern in the orientation of these lobate scarps, suggesting that there is some outside influence. Hint, it's us. Well, the Earth more specifically. Thrust faults form when one block of crust slides up another and are commonly found on Earth in mountain ranges such as the Himalayas, but they're also found on Mercury. Mercury's globally distributed fractures suggest the planet's mantle has cooled, shrinking its interior and distorting the crust. Similar structures have been found on the moon, captured in images from NASA's Lunar reconnaissance orbiter. To date, nearly 3/4 of the moon's surface has been imaged, showing us smaller versions of the scarps found on Mercury, but with one big difference. Earth's gravity is affecting how these scarps are appearing on the moon's surface. Without our gravity, the lobate scarps would be evenly distributed with random orientations. But that's not what we see. Instead, near the equator and mid-latitude regions, most of the scarps were oriented north-south, whereas at the poles they were mostly east-west. Researchers say that these findings are consistent with the Earth's gravitational tidal forces affecting the moon's surface. Interestingly, the lobate scarps are geologically young. They are estimated to be less than 1 billion years old, and some of the youngest only 100 million years old. Granted, to us, that age seems unfathomable, but they are less than 25% of the age of the moon. In relation to the age of the universe, that's nothing. The age estimation comes from the scarps appearing to cut across small craters. Because the moon is constantly bombarded by meteors, the small craters are usually replaced by larger ones relatively quickly. So if the lobate scarps are cutting through these young craters, they must have formed later in time. So then what is the fate of our moon? Well, if the moon continues to cool and contract, it is likely to form new lobate scarps, likely following the same pattern of orientations. The shrinking size, roughly 100 meters over the last billion years, is unnoticeable to us. As the moon continues to get further from us every year, its decrease in angular size will far outweigh its change in physical size. Of course, in about 5 billion years, when the sun burns through the hydrogen in its core, it will expand into a red giant. And at that point, the moon's compression will be the least of its worries. Do you think we have a chance of surviving when that time comes? Let us know in the comments. Even though the moon is shrinking, it can look much larger when it is near the horizon. To find out how this illusion works, check out my video over on my channel, Explorium. For example, if I'm standing next to the tree, we can use my height to determine the trees with some uncertainty. And sure, we could say that the tree is relatively tall. But what about now? Would you still say the tree is big? If you're on mobile, you can find the link in the description. Thanks for watching DNews and subscribe for more.